Ever heard of cosmic rays? These high-energy particles constantly bombard Earth from outer space. We know about them thanks to a scientist named Victor Hess, who discovered them on a balloon flight in 1912 and won a Nobel Prize for it. But what if I told you the story is more complex? What if the real discoverer was a brilliant Italian scientist, whose groundbreaking work was lost to history? This is the story of Domenico Pacini, the forgotten father of cosmic rays. Our story begins in the late 19th century in Italy. Young Domenico Pacini was a curious boy, captivated by the natural world. Instead of just playing on the sun-drenched streets, he was often found with his nose in a book or exploring the countryside, fascinated by the unseen forces that shape our universe. This childhood curiosity propelled him to the University of Rome, where he dove headfirst into the world of physics. Imagine the old grand lecture halls, the air thick with chalk dust, where Pacini learned from the great minds of his time. He wasn't just a student, he was a detective of the cosmos, eager to solve its biggest mysteries. After graduating, Pacini became an assistant at the Central Office of Meteorology and Geodynamics in Rome. This is where his journey into the unknown truly began. At the turn of the 20th century, scientists were puzzled by a strange phenomenon. An electrometer, an instrument used to measure electric charge, would slowly lose its charge no matter how well it was insulated. This suggested some kind of invisible, penetrating radiation was all around us. Where did it come from? Most believed it originated from radioactive elements in the Earth's crust. But Pacini had a different idea. He was a meticulous researcher, spending countless hours in his lab, surrounded by early, clunky instruments, poring over scientific papers by candlelight. He suspected the radiation might be coming from somewhere else entirely, somewhere above. To test his hypothesis, Pacini needed to isolate his instruments from earthly radiation. He reasoned that if he could shield his detector from the ground, he could see if the radiation levels changed. He tried experiments on land, comparing measurements on the ground to those on a high building, but the results were inconclusive. He needed a better shield. And then, he had a brilliant, almost audacious idea. What if he submerged his detector in water? Water is dense and would be an excellent shield against radiation coming from the seabed. If the radiation was truly from the Earth, its intensity should decrease significantly underwater. He meticulously planned his experiment, sketching designs for a waterproof case and scouting locations along the Italian coast. In June 1911, Pacini took a small boat out into the Gulf of Genoa. As the sun set, casting a golden glow over the water, he carefully lowered his specially designed electrometer 3 meters below the surface. This was a pivotal moment. Imagine the scene: a lone scientist on a boat, the gentle lapping of waves as he submerges his creation into the dark water, bubbles rising to the surface. He wasn't just conducting an experiment, he was challenging the established scientific consensus. He took readings for hours, patiently recording every detail in his notebook, both on the surface and deep underwater. Back in his lab, Pacini analyzed the data. He compared the rate of discharge on the surface of the sea with the readings he took underwater. The results were astounding. The charts and graphs told a clear story. The radiation was significantly weaker underwater. It had decreased by about 20%. This was a crucial piece of evidence. If the radiation came solely from the Earth's crust, the water should have blocked nearly all of it. The fact that a significant amount of radiation remained could only mean one thing: it was coming from above, from outside the Earth's atmosphere. In his notes, Pacini wrote with conviction, "It appears that a sizable cause of ionization exists in the atmosphere, originating from penetrating radiation, independent of the direct action of radioactive substances in the crust." He had found the first concrete proof of extraterrestrial radiation. Excited by his discovery, Pacini wrote up his findings and published them in an Italian journal, Il Nuovo Cemento, in early 1912. He sent his papers off, hoping to share his revolutionary conclusion with the international scientific community. He had done everything right. He formed a hypothesis, designed a clever experiment, and found compelling evidence. But fate had other plans. His work, published in Italian, went largely unnoticed by the wider scientific world, which was dominated by English, French, and German publications. Then, just a few months later, in August 1912, the Austrian physicist Victor Hess made his famous series of high-altitude balloon flights. He carried electrometers up to an altitude of over 5,000 meters and found that radiation levels increased dramatically with height. This was spectacular, direct proof that the radiation came from space. Hess's daring balloon ascents captured the world's imagination. His experiment was dramatic, visual, and easy to understand. While Pacini's careful underwater measurements were scientifically sound, they lacked the theatrical flair of Hess's journey into the sky. The world celebrated Hess as the discoverer of what would later be named cosmic rays. He was awarded the Nobel Prize in Physics in 1936 for his discovery. Pacini was never even mentioned. To make matters worse, World War I erupted across Europe, disrupting scientific communication and shifting focus away from pure research. Pacini's groundbreaking work was buried under the weight of history, overshadowed by a more dramatic experiment and lost in the chaos of war. We can only imagine his frustration, sitting alone in his laboratory, surrounded by his data, knowing he had been the first, yet receiving no credit. For decades, Pacini remained a footnote in the history of physics, if he was mentioned at all. He continued his career as a respected physicist and meteorologist in Italy, teaching a new generation of scientists, but the recognition he deserved for his cosmic ray discovery never came in his lifetime. He passed away in 1950, his contribution all but forgotten. But the truth has a way of coming out. In the late 20th and early 21st centuries, as historians and physicists begin digitizing and re-examining old scientific archives, Pacini's work was rediscovered. Modern scientists, looking at his papers from 1912, were stunned. They saw the clarity of his logic, the ingenuity of his experiment, and the inescapable conclusion he had reached. Today, the scientific community widely acknowledges that Domenico Pacini was, without a doubt, the first person to provide concrete experimental evidence for the existence of cosmic rays. He beat Victor Hess by several months. His instruments are now displayed in museums, testaments to his ingenuity. Tributes are paid to his memory, and his story is finally being told. The animated timeline of discovery has been corrected, with Pacini's name and his underwater experiment in 1911 now placed firmly before Hess's balloon flight in 1912. Domenico Pacini's story is a powerful reminder that history isn't always written by the victors, but often by those with the loudest voice or the most spectacular show. He was a quiet, meticulous scientist who sought truth, not fame. He may have been forgotten for a century, but his legacy as a true pioneer of physics is finally secure. He is the forgotten father of cosmic rays, and his journey teaches us that even when recognition is delayed, a brilliant discovery can never truly be lost. Thanks for watching. If you found this story as fascinating as I did, please like this video, subscribe to the channel, and hit the notification bell so you don't miss our next journey into the hidden corners of science and history.